non-proportional relationships. Don't get mixed up and think that if something's non-proportional, that it also is non-linear, because if we look at this example that we have here, without a doubt, this one is linear. It's a straight line. And we are going to write an equation in function notation for the relation graphed at the right. So here's the deal. You are told to get the ruler out, so let's make that happen right now. And the reason I want you to get a ruler out, so pause it if you need to go get this from your binder, is because we're going to look at this relationship between these numbers. And I'm going to use the blue ones, not so much here right now. Take your ruler and line it up neatly on this second blue line, perfectly vertical in that position. With that in place, trace a line, draw a line, vertically down, but make sure you don't go past 5, because this would be the vertical height showing you from 7 to 5. Next, take your ruler, place it below the blue, butt it up right next to that blue dot, and then connect the blue dot to that other green line so that this forms a very clean and a very clear 90-degree angle right there. And I want you to see that this is a step. It's like you're stepping up. And as we label this, we talk about the vertical distance first, which is what I drew first. So this looks like it is increasing by 2. So let's write plus 2. And it increases by 2 as it moves to the right only 1 unit. And I know this is 1 unit because my eyes go all the way down. There's the number 2. There's the number 1. I'm not dealing with a graph where my steps on my x-axis are a greater distance. Oops, sorry about that. And let's repeat the process 2 more times so that we can see that these steps never change. It's always going up 2 and over 1. And I think I might have misspoke there. Make sure you put a plus 1 there for the x distance. I think that was clear, though I just kind of jumped. So yeah, I see that it goes up 2 every 1 that it goes over, up 2 every 1 that it goes over. And we could have drawn these triangles on the other side as well, up 2 over 1, up 2 over 1, up 2 over 1. And the reason that I am talking about the graph right now is because we're going to also deal with the table in a moment. So let's set up a table where we see 0, 1, 2, 3, 4. And I'm looking and I'm seeing, well, at 1 I have a value of 5. On purpose I'm skipping 0 for now, I just kept it as a placeholder. At 2 I have a value of 7. At 3 I have a value of 9 and 4, 11. Which is good, because again, on my graph I'm seeing the same thing in my table. Plus 2. Plus 2. Plus 2. And what this means is that if we were doing the last chunk of problems where they were proportional, and I had y equals kx, I'm writing that in red, we would have been like, well, it's got to be y equals 2x. Because repeating that 2 again and again and again implies multiplication. But I got a little bit of a problem, because if I wanted to try to test this out, well, 2 times 1 gives me, 1 times 2, I'd like to say it that way, gives me 2, and not 5. 2 times 2 gives me 4, but not 7. 3 times 2 gives me 6, but not 9. And 4 times 2 gives me 8, but not 11. But it looks like I could fix these problems somehow. How would I get to 5 from 2, 4 to 7 from 4, 9 from 6, 11 from 8? And if you see it, awesome. If not, it'll come with time. It looks like I could fix this by adding on a value of 3 to my problem. And the other thing too is if I walk back in my table from 11 to 9 to 7 to 5, then I could see that my next step would have to be 3, which I'll write in green so that it matches, because 2 times 0 would go away, and I'd have to add 3 to fix that. The other thing too is, where x is 0, that means I'm here on my graph. And if I look at my graph and I go all the way up, there's that value of 3, which is my starting point. So I've talked about 3 in the equation, 3 in the graph, and 3 in the table, and shown it a bunch of different ways to hopefully make this feel stronger. So let's say you move forward and you start doing some bookwork. When you move forward and you start doing bookwork, if you get to one of these problems and you haven't tried to turn your graph that you are given into a table and looked for a pattern, you haven't done enough. If you've been given a table and you haven't shown this, you haven't done enough. So you got to make sure you're trying to look at this as many ways as possible to help yourselves with taking care of it. And because of that, go ahead and see if you can figure out this one on your own. I'm still going to talk about it, but I'd like you to challenge yourself by figuring it out on your own. So spend a few minutes pausing this video and see if you can get to the end result where we have an equation and function notation for what you see in this table. 5 seconds, I'm going to start talking about it. Maybe you notice that you're subtracting 1 every time. And if that's repeated, then that kind of implies that you're going to have something that starts looking like a proportional relationship of -1 times x. Now, go ahead and do this exercise anyway. We'll set up x here on the left. We're going to do a vertical table. Then we're going to set up -x, which is the same as this -1 times x. And we're going to see how close that gets us to what we hoped to have for this set of y values. So here's x, here's -x, and I do like to kind of include 0 here. And I'm going to budget my space 1, 2, 3, 4. Now if I take the values in x and I use this equation that I'm working on so far to create -x, well, 0 times a -1 doesn't matter, so that's still 0. -1 times 1 is -1. -1 times 2, and so on. It's just making all these values negative. But the issue is, these values do not match up with my y. And since they don't match up with my y, I'm going to write those y values in here. And I'm going to start looking at it and say, well, how could I fix it? Well, first of all, if I look at the pattern, I can predict what value I would have in this row, because as I step back, I'm going up 1, 2, 3, 2. There it is. It would have to be a 4, right? Well, I guess that means that if this was gone, because anything times 0 goes away, I'd have to fix my problem by adding 4. And I think that works out. But let's pretend I didn't approach it that way. Let's say I took a different step towards it. -1, how would I get from -1 to 3? Because this is what I guessed it should be, but it's not quite right. How would I get from -2 to 2, -3 to 1, and -4 to 0? Those all could be fixed by adding a value, and even though there's negatives involved, pull out a calculator, subtract them, do whatever you got to do. but you would see that these would all be fixed by adding 4. So hopefully you were able to see most of that in the patterns and everything. If not, practice is going to help you out in asking questions. So here's the assignment that'll go with that. Let's see how it goes. This is the second video of 2 on proportional and non-proportional relationships.